Hello students. In this video, we're going to learn how to graph sinusoidal functions. And I have this first problem right here. F of x equals to 2 sine of x over 2, which means a is 2 and b is half. C and D are both 0. So first, that a value indicate that the amplitude of this function is 2. The midline is 0, so D is 0 being means the graph is oscillating about the x-axis. There is no vertical shift. Period, which is calculated by dividing 2 pi by b, is going to be 4 pi. Now, there's one thing I always do is to determine the scale of the graph that will help me in plotting the 5 critical points. So scale will always be determined by dividing period by 4, which in this case will give me pi. So since I'm graphing the sine function, I'm going to start at the midline, which is 0. And there's no phase shift, so 0 comma 0. And then at the pi is going to go to the maximum value. This is not pi. Maximum value, which is 2. And then at another pi, which means that 2 pi is going to come back to the midline. Ideally, I should have a little longer x-axis and I should have a complete cycle, but if I don't have it, I can go to the left side at negative pi is going to be at -2, and at 2 pi, -2 pi is going to come back to the midline. So this is since this is a continuous graph, you really can just pick up that wave anywhere as long as the points that I'm plotting are correct points. This graph is going to continue. So this is -2 pi to 2 pi, still has a period of 4 pi, as you can see. And the graph points are all correct because 0 at 0, your function value is 0. At pi, it will be 2, and 2 pi, it will be back to 0, and so forth. Okay, so I'm going to pause here for a second and let you identify the values of A and B for our second equation. Perfect. So A is 3 and B is 2. C and D are 0 again, which means the amplitude is 3 period, which is 2 pi over B is pi. That means there's a horizontal shrink in the graph. The one we saw before had a horizontal stretch. We're going to write down our scale, which is period divided by 4. So in this case, it's pi over 4. No phase shift, no vertical shift, but there is a reflection about y-axis. I'm sorry, deflection about the x-axis. Now, how we show reflection for the cosine is that it's going to start from the minimum instead of maximum. So at 0 is going to be -3. There's no phase shift. So at 0, it's at the minimum point. Next point, critical point, is going to be at an increment of pi over 4. So pi over 4 is going to be at the midline. Then it's going to go to the maximum value of 3 at pi over 2, come back to the midline. And at pi is going to complete one cycle. And since I have more space, I would like to continue this trend for a little bit. Let's graph this piece here. At 3 pi over 4, I'm going to be back to the midline. Sorry, this was 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and at 2 pi, I have 2 cycles of this function. And this trend can continue on the left as well. And I actually have 4 cycles after this. And still continues. All right, so for our next equation, I will pause and let you determine the values of A, B, C, and if there is any D. All right, hope you had the correct answer here. A is 2, B is pi over 3. Now for this C, I'm going to have to divide C by B. Remember that because here B is being multiplied. So the amplitude is 2. This also has a reflection over the x-axis. Period, which is 2 pi over B, is going to give me 6. Okay. Scale, which is period divided by 4, is 3 over 2, which is 1.5. And, or 3 over 2, you could write. And the phase shift, I'm going to do negative negative C over B, which is negative pi over 6 times 3 over pi, which is negative half. So negative 0.5 or negative half to the left, no vertical shift, and there is a reflection. How the reflection looks like for the sine is that from the midline, it goes down first. There's usually one thing that I do is to put this bx minus c function between 0 and 2 pi just to help me know where the starting and ending point is for one cycle. So this is kind of optional at this point. If you feel like it's helpful, then use it. But if you feel like, oh, I know that it has shifted negative half, so I'm going to start right here. I don't have to really use this, and that will be absolutely fine. So I'm going to just use it because, like I said before, it's just an option to use. It just helps in starting and ending point. So first, just like you solve any other inequality, I'm isolating x in the middle. I will first get rid of the constant term, so I will subtract pi over 6 from all three sides. 2 pi, I'm going to actually write here, 2 pi minus pi over 6 is 11 pi over 6. And then times 3 over pi everything. So let me see if I can change the color. Times the reciprocal of pi over 3, which is 3 over pi, will just give me x in the middle. And when I multiply out, I get negative half on this side and 11 over 2 on this side. So 11 over 2 is basically 5.5. So if I'm starting here and I'm going as an increment of 1.5, I'm going to end at 5.5. Since I started half left of 0, I'm going to end up a little bit before 6, right? Half points before 6 to be exact. So since it has a reflection, I'm going to go down after half, 1.5 point means at 1 is going to be at -2, and at 2.5 it's here, and at 4 is going to be at the maximum, and then at 5.5 is going to be back to 0. This is really just one cycle of this sine function. Usually when there are a lot of transformations, we make students just do one cycle, but if you do want to graph more than one, I mean, you just kind of continue the trend. So 1.5 is going to be at the maximum, 1.5 from here is going to be at the minimum, 1.5 from here is going to be back here on the midline. This kind of looks a little messy. I think I probably didn't go with the 1.5. So this is 1.5 and this is 1.5, and then this is 1.5. All right, this trend just continues. Again, we found the amplitude, we found the period, we found the scale, we found the phase shift, and pretty much all that is needed. And reflection over the x-axis means from the midline is going to go down first. This helps us in kind of identifying the starting and the ending point just for one cycle that incorporates all the phase shift and the horizontal stretch or string. So hopefully you found that helpful. Thank you.